Just of US students. We have a whole bunch of attributes about them: their gender, age, what hand is dominant, how tall they are. You can see some real bad data quality problems here. How tall is this woman? She is 9 centimeters tall. It's really frustrating data quality issues. They also allowed people to write things. You find like words in here. So we're going to come over here to how many text messages do you send? And one person wrote a lot, which messed up the analysis because you can't have a word in there. So what we're going to do is take this and we're going to open up XLSTAT and then modeling data, linear regression. The question we're trying to answer is the relationship between number of hours spent hanging out with friends and the number of text messages you received yesterday. All right, so there's a lot of variance here in how much people hang out. We come down, these are some of the numbers we want to look at. You can see that our R-squared value, which is the proportion of variance that's explained by the model, is extremely small. There's not very much that this model is explaining. And then for our F value here on the ANOVA, this is whether or not all the values in our regression could just be 0, and we can't reject that, right? So we could basically say this model is not useful at all. We get a value for time spent hanging out. And you can see this is not statistically significant. It's less than a critical value. This is greater than alpha. So how do we get this value? Well, you can take this value divided by this value, and these will be the same. And then to go from here to this value, we can just use our t-test. Degrees of freedom. Let's see, it should be like number of observations minus 2. There we go. Let's try false. Nope. There we go. It's going to be 1 minus that. There we go. Nope. Oh dear. But that's where this number comes from. So this model, not useful at all. Let's try a different question then, since the amount of time you spent hanging out with friends doesn't work. How about the number of messages that you received yesterday? Right, we've got these outliers here. I'm going to just filter them out. 5,000 messages. Seems unusual. All right. So XLSTAT, modeling data, linear regression. Still going to keep my same goal. How many messages did you send? But instead of using time spent with friends, I'm going to use number of messages you received. So the idea is the more messages you receive, the more you probably send. Let's see if that's true. I want to use the filtered version of my data. Okay, so the proportion of variance that's explained by this model is much higher than what we just saw. So 68% of the variance in the model can be explained by this. You have a very different result. The probability that the coefficients here are equal to 0 is very low. Right? That's good. And here are our values. again, to get the t-value is equal to the value here divided by the standard error. These are our confidence intervals, lower bound and upper bound, for what the coefficient here could be. So if I wanted to estimate how many messages that somebody was going to send, I know that she got, let's say, so it's going to be 12 here times this value, 12 plus this value, and how many do we want to say she received yesterday? Let's say she received 30 messages. So the estimated number of messages she sent is 32. We can come down here and we can actually see a whole lot of information about what was calculated, including a prediction. So this is the predicted number of text messages sent in the actual. So if we had somebody that received 500, but then they sent 50, the predicted was 350, but that was off by 300. And that gives it for all of our observations. Excellent. So we just did the linear regression. Easy peasy, lemon squeezy. Let's do the same concept, but instead of using XLSTAT, we'll switch over and use our Data Analysis Toolpak. Clicking on regression, my y's are going to be need to move over a little bit. Okay, number of text messages sent. My x values are number of text messages received. I want a confidence level, and let's go ahead and see a line fit plot. Oh, look up labels. Okay, so I've now done this, and somehow I messed this. Oh, it's the filtering. That's what the Excel version can't handle filters. So we will put everything back in. Now, here we go. This should work. Oh, dearie. There we go. Hooray. And it's done. This gives us slightly different values because it's not filtered. You can see it really changed our square because we had those extreme values in the data set. Just remove them the old-fashioned way. I will right here. these top values and delete them. And run this again. Okay, this is what we got from XLSTAT, and this is what we have from XLSTAT. Okay, you can see it's the same values, presented slightly differently, but the exact same values.